2,800 metric tons of sulfur dioxide are released every 24 hours from one volcano. That is enough poison gas to create a death zone spanning the entire Tokyo metropolitan area. Yet, it is pouring from Sakurajima's crater, while Japan maintains only Alert Level 3, as if this atmospheric assault is somehow routine. But atmospheric chemists analysing the gas signatures made a discovery that changes everything. This is not surface degassing from normal volcanic activity. The isotopic fingerprint matches magma rising from depths of 15 plus kilometers, the exact zone where Sakurajima connects to the ancient Aira Caldera chamber that has not been active for 22,000 years. When the same underground system that once ejected hundreds of cubic kilometers of material across Japan starts bleeding poison into the sky at industrial scale rates, it is not venting pressure. It is announcing its return. How much toxic gas can one volcano release before it becomes a weapon against an entire nation? When atmospheric monitoring shows this poison cloud now circulating in jet streams above the Pacific, who decides which countries get to breathe clean air? Sakurajima, a 1,117-metre stratovolcano towering over Kagoshima Bay, is no stranger to explosive tantrums. For over 1,300 years, this volatile giant has been a constant source of both terror and fascination for the people of southern Japan. The first documented eruption in 708 AD marked the beginning of a relentless cycle of destruction and rebirth that has fundamentally shaped the region's history and geography. Throughout its long and violent history, Sakurajima has been known for its near-constant state of activity. Most eruptions follow a predictable strombolian pattern with small-scale bursts of ash and lava that affect only the immediate summit area. However, the volcano's true destructive potential is revealed during its cataclysmic Plinian events. These events have occurred 3 times in recorded history, from 1471 to 1476, from 1779 to 1782, and most recently in 1914. Under normal conditions, Sakurajima emits between 100 and 500 tons of sulfur dioxide daily. It is a toxic gas that can cause respiratory distress, acid rain, and long-term environmental damage. Prior to major explosive events, these emission rates typically escalate to between 800 and 1,200 tons per day. At the peak of its most violent eruptions, Sakurajima has been known to release up to 2,000 tons of sulfur dioxide in a single 24-hour period. However, the current emission levels have shattered all historical precedents. As Dr. Setsuya Nakada, a volcanologist at the University of Tokyo, emphasizes, in 50 years of monitoring Sakurajima, we have never recorded sustained emissions above 2,000 tons daily. 2,800 tons during Alert Level 3. Free activity has no precedent. To understand the true scale of the threat, one need only look back to the catastrophic eruption of 1914. Over the course of several months, Sakurajima ejected an astonishing 3 billion cubic meters of ash and lava, transforming the once isolated island into a peninsula connected to the Japanese mainland. The ash plume reached as far as Hokkaido, over 1,200 kilometers to the north, while earthquakes associated with the eruption claimed 35 lives. But perhaps the most significant revelation from the 1914 event was the confirmation of Sakurajima's deep connection to the much larger Aira Caldera system. As the volcano expelled massive volumes of material, the center of the caldera dropped by 60 centimeters, proving that Sakurajima was merely a vent for a vast underground magma chamber. Fast forward to January 2026, and the warning signs are impossible to ignore. Sakurajima is now releasing 2,800 tons of sulfur dioxide every single day, a staggering 40% higher than any previous measurement. Even more alarming is the chemical signature of this gas, which bears the isotopic fingerprint of magma originating from depths of 15 kilometers or more. Despite these unprecedented readings, the Japan Meteorological Agency, JMA, has maintained Sakurajima's alert level at a moderate level 3, indicating an increased likelihood of explosive activity, but stopping short of ordering evacuations. Meanwhile, satellite data confirms that the toxic plume is reaching the stratosphere, contaminating the air at altitudes used by commercial aviation. As Dr. Hiroshi Shinohara, a volcanologist with the National Institute of Advanced Industrial Science and Technology, AIST, warns, when gas signatures match deep caldera sources rather than shallow summit activity, we're not monitoring a normal eruption cycle. We're watching a caldera system wake up. To grasp the full implications of Sakurajima's escalating emissions, one must first understand the complex and interconnected nature of the Aira Caldera system. This massive subterranean chamber, measuring 25 kilometers in diameter, last erupted approximately 22,000 years ago in a cataclysmic event that produced hundreds of cubic kilometers of ejecta and fundamentally reshaped the geography of southern Japan. Since then, the caldera has remained largely dormant, with only sporadic activity at its associated vents, like Sakurajima. However, recent discoveries have confirmed that the two systems are intimately linked, sharing a common magma reservoir deep beneath the Earth's surface. The evidence for this connection is multifaceted and compelling. During the 1914 eruption, the subsidence of the caldera floor proved that Sakurajima was tapping into the same vast pool of molten rock that once fueled the Aira supervolcano. Now, the chemical composition of the gas emissions further corroborates this link, with isotopic ratios matching the ancient caldera materials rather than the younger magma typically associated with Sakurajima's activity. Moreover, ground deformation measurements using state-of-the-art GPS technology have detected a subtle but unmistakable pattern of inflation across the entire caldera region, suggesting that magma is once again accumulating in the deep reservoir. This observation is further supported by changes in the seismic activity beneath the volcano, with a notable increase in deep earthquakes indicating the movement of magma at depths corresponding to the caldera system. Dr. Masato Iguchi, director of the Sakurajima Volcano Research Center at Kyoto University, explains that when Sakurajima's gas emissions show deep caldera signatures, we are not just monitoring a volcanic vent. We are watching the reactivation of one of Japan's largest underground magma systems. The implications of this reawakening are nothing short of catastrophic. At its current emission rate, Sakurajima is releasing enough sulfur dioxide to rival the output of entire industrialized nations, effectively weaponizing the atmosphere on a regional scale. The toxic gas, which can cause respiratory distress, acid rain, and long-term environmental damage, is now being injected into the stratosphere, where it can circulate globally and impact the health and well-being of millions. For the 680,000 residents of Kagoshima, located just 8 kilometers from the smouldering crater, the threat is existential. A sudden shift in wind patterns could concentrate the poisonous plume over the city, causing widespread respiratory emergencies and overwhelming the local healthcare infrastructure. The island geography of southern Japan only compounds the danger, creating natural bottlenecks that could hamper evacuation efforts in the event of a full-scale eruption. But the risks extend far beyond the immediate vicinity of the volcano. With over 13 million people living within the potential atmospheric impact zone, a major eruption of the Aira Caldera could devastate the agricultural heartland of southern Japan, contaminating crops and water supplies with lethal concentrations of acidic pollution. As Sakurajima continues to belch out its noxious cocktail of gases at an unprecedented rate, the scale of the atmospheric crisis becomes increasingly apparent. Toxic exposure zones are expanding daily, with measurable impacts on air quality extending over 100 kilometers from the volcano. Commercial flights passing over the region have reported detecting the acrid plume at cruising altitudes, raising concerns about the safety of aviation in the region. On the ground, the situation is even more dire. Acid rain, formed when sulfur dioxide reacts with atmospheric moisture, is now falling across much of Kyushu, the southernmost of Japan's main islands. Agricultural fields are withering under the onslaught, with reports of crops being burned by the caustic precipitation. In a worst-case scenario, a sudden shift in wind patterns could concentrate the entire 2,800 tons a day of sulfurous gas directly over Kagoshima, a city of 680,000 people. The resulting wave of respiratory distress would quickly overwhelm local hospitals, while the corrosive rain would strip paint from vehicles and burn the skin of those caught outdoors. Evacuation routes would become clogged as panicked residents flee the advancing poison, creating a humanitarian disaster of unimaginable proportions. The economic implications of such a catastrophe are equally staggering. Southern Japan is a vital hub of manufacturing and agriculture, with the region's industrial output playing a critical role in global supply chains. A prolonged disruption caused by volcanic pollution could send shockwaves through the international economy, exacerbating existing strains on the fragile post-pandemic recovery. Dr. Alan Robock, a climate scientist at Rutgers University, warns, "When one volcano can inject 2,800 tons of sulfur dioxide per day into the stratosphere, you are looking at regional climate modification capability rivaling industrial geoengineering projects. The sheer volume of gas being released has the potential to alter weather patterns across the Western Pacific, with unpredictable impacts on temperature, precipitation, and storm systems. In essence, the volcano is conducting an uncontrolled experiment on the planet's atmosphere, with consequences that could reshape the environmental balance for years to come." Despite mounting evidence of an impending atmospheric catastrophe, the official response to Sakurajima's escalating emissions has been muted. The Japan Meteorological Agency has maintained the volcano's alert level at a moderate level 3, indicating an increased likelihood of explosive activity, but stopping short of issuing evacuation orders. This decision reflects a troubling gap in the current volcanic risk assessment framework. While existing protocols handle the localized impacts of a typical explosive eruption, they are woefully inadequate for addressing the large-scale atmospheric contamination now emanating from Sakurajima. Dr. Setsuya Nakada, a volcanologist at the University of Tokyo, warns that we are monitoring atmospheric emissions that exceed our crisis protocols, but the volcano has not technically erupted. We are in uncharted territory, where our alert systems may be inadequate. The lack of a comprehensive atmospheric monitoring network capable of tracking the volcanic plume in real time only compounds the problem. Without a clear understanding of gas concentrations and dispersal patterns, authorities are left guessing at the true extent of the danger. Even more concerning is the possibility that Sakurajima's emissions could continue to escalate indefinitely, even in the absence of a visible eruption. The reactivation of the Aira Caldera system, after a slumber of 22,000 years, is a process that operates on a timescale far beyond human experience. No existing models can predict when or how this ancient supervolcano will fully awaken, leaving society vulnerable to an unprecedented atmospheric threat. Perhaps most alarming of all is the risk of regional synchronization, where the stirrings of the Aira Caldera could trigger sympathetic activity in other volcanic systems across Japan. The archipelago is home to over 100 active volcanoes, many of which are located in densely populated areas. A cascade of eruptions, each contributing its own toxic burden to the atmosphere, could quickly overwhelm even the most robust disaster response plans. As the world watches the skies over Japan with growing unease, the central question becomes impossible to ignore. How much longer can we tolerate the weaponization of the atmosphere by forces beyond our control? If Sakurajima can unleash 2,800 tons of sulfur dioxide every day while still considered stable, what nightmarish scenario awaits when the Aira Caldera finally rouses from its slumber? How do you protect a population of millions from an invisible poison that moves faster than any human evacuation could hope to match? And if the very air we breathe becomes contaminated on an industrial scale, what future remains for a civilization that depends on the purity of the atmosphere for its survival? The answers to these questions may determine the fate not only of Japan, but of the entire planet. As the toxic plume from Sakurajima spreads across the Pacific, carried by the vagaries of wind and weather, it becomes increasingly clear that the threat of atmospheric volcanic warfare is no longer the stuff of speculative fiction. The battle lines have been drawn, and the stakes could not be higher. On one side, the raw, primal fury of the Earth's molten heart. On the other, the fragile web of human society, sustained by the delicate balance of an atmosphere we have long taken for granted. The outcome of this conflict will reverberate far beyond the shores of Japan. For now, all eyes turn to Sakurajima, where the first shots have already been fired in a war that could ultimately engulf us all. The Japan Meteorological Agency may still classify the volcano as stable, but for those who have glimpsed the true scale of the threat, there can be no mistaking the gravity of the situation. 2,800 metric tons of sulfur dioxide every single day. A poison in the sky. A harbinger of the cataclysm to come. The Aira Caldera is stirring from its long slumber, ready to unleash its fury on a world unprepared for the consequences. This is not the script for some far-fetched disaster movie. This is the new reality of life on a planet where the very air we breathe can become a weapon of mass destruction. And as the sun sets over the smouldering peak of Sakurajima, one thing becomes inescapably clear. The era of volcanic atmospheric warfare has begun, and nothing will ever be the same again. Stay ahead of the unfolding disaster with Earth Attacks, your source for cutting-edge analysis and expert insights into the dark side of our planet's raw power. Subscribe now to ensure you never miss a development in this unfolding crisis.